So, my name is Jonas Wagner. I work at local at CH as software engineer. But today I'm going to talk to you about how to use HTML5 to develop games. So it's kind of cool because it's, in a way, a follow-up to the previous talks by Dominic and Marcus that showed you some features of HTML5. I will now show you how you can use those to actually create games. So my schedule will be I'll talk about why you would want to use HTML5 to write games and why you would want to write games at all. I talk about graphics and how you can do efficient rendering. I'll talk about audio and why it's so painful at the moment. I'll do a short one on input, multiplayer. This is where I'll basically join with Dominic's talk, I guess. Physics, and my little conclusion. So, why would you want to write games? Probably the first thing is because you like games. If you like games a lot, like I do, and you like web technology a lot, like I do, it makes a whole lot of sense to combine those two and to, in a way, combine your passion. It has also helped me a lot. It really taught me to appreciate JavaScript and understand it properly with all the nifty little details of it. Also because with games, you're really pushing your platform, your browser. You will learn a lot about it, more than you do when you do normal web development. But you can still apply this knowledge to normal web development because in games, you need a whole lot of performance because it just doesn't work otherwise. On a normal website, you get away without it being super fast, but it's still very nice when it is. So let's go ahead to graphics. There's a relatively big debate in the HTML5 gaming crowd on what you should use for rendering. There's basically Canvas 2D. There's WebGL, which is this 3D thingy. It's very close to OpenGL and its C API. You can use HTML with diffs and CSS transforms for rendering. And you can also use SVG to have it scalable, which in a way makes a lot of sense because with the diverse nature of the mobile web we have, for example, but also on the desktop, you have to support a whole lot of different resolutions. There's no way around it. So what should you use? I would say all of them. Use Canvas for rendering. Use WebGL when you need 3D special effects or other really processing-intensive stuff. Basically, WebGL gives you direct access to the GPU. And I'll later show you an example of what you actually can do with it. You should use HTML for the UI. Because you have much better support for events. You can actually register a click handler on a button, which Canvas simply doesn't know about. With Canvas, you get a click at XY, and it's up to you to figure out, hey, there is something at XY. Hey, I have an event handler for that. Hey, let's call it an event handler. It doesn't make sense. For example, I saw a Stack Overflow post and somebody asking, how do I implement an input field in Canvas? Well, the answer is obvious. You don't. You have HTML. Put the input thing there and use it. It's very hard to get an input to behave right when you implement it yourself anyway. Another common misconception is that JavaScript is slow and Canvas is slow and everything is slow on the web. I don't think so. This is 10,000 particles. No, it's 100,000 particles influencing each other. It's not even using WebGL or workers or anything. This is plain old Canvas with barely optimized code. And it's running really quick. You can see it's slightly shaky now. And that's Firefox. That's not Chrome. But what if you need even more? What if that's not enough? What if you want crazy graphics? Well, you can do WebGL. With WebGL, you can do things like that. This is a demo I did. You can see reflections. You can see through the water. It's actually rendered all in HDR. And I mean, really, what you can do with it is impressive. On the last conference, there was an HTML5 gaming on GameStart. There was a guy showing a demo of running a Team Fortress 2 level on WebGL. It actually looked really good. So you're barely limited by it. But this is the statistics that I had collected with Google Analytics when running this demo. You can see that on Windows, about 60% of the people who viewed this couldn't actually see it. It's nice, it falls back to a YouTube video, but for a game, this is not really an option. Now, this is the readers of my blog. A big part of them is coming from websites like Chrome Experiments. So they actually have high-end PCs, usually very updated browsers. As you can see, the most used browser is actually Chrome. And still you have all these problems. So it will take time to become really usable. Audio. Audio is horribly, horribly broken for gaming. The way the audio element in HTML5 is implemented is really designed for streaming music, for streaming talks. With audio, I want to play a small file right now, and I want to play all of it. Currently, browsers play a selected slice of your short file after some delay, which is very horrible for gaming. One way I've found to work around this is to use pooling and the HTML5 caching manifest to force them to be in the cache, but even then, it's still a lot of trouble. And best of all, on iOS, you cannot even play audio except in a click handler. Thanks. The cool thing is there's upcoming audio APIs from both Mozilla and Google. They're actually both of them are different. But I think by now, both of them are in stable browsers. They allow you to do really cool stuff, like convolution reverb, which is like really high-end reverb that you can do. So you can simulate different environments. You can do, you can change the rate. You can do even, in the Chrome version, you can even do surround sound for your 2D JavaScript game. Oh, well. Input handling. I tried to keep this really quick. It's not all that interesting. Basically, you can use normal DOM input handling that works quite well for the keyboard and the mouse. There's no support for awesome gamepads. There is support for touch devices, but it only properly works on iOS. On Android, you only get one touch, and even that one is buggy, which is not entirely helpful. The other thing is with the mouse, you cannot currently capture the mouse and say, hey, if he moves out of the window, the user is still playing, and he hates when he loses control of his little man because of this. And he dies, and it's game over. Makes him really angry. A current trend in all games, it's probably started with Half-Life 2, with physics and physics engines, or to be more accurate, mechanics that actually work. What you can see here is a port that I did of Box2D, which is the library that powers things like Angry Birds and whatnot. The good thing is that the thing stole my click handler, and that there are a lot of Box2D ports. The problem is that all of them suck. And I think I'm allowed to say that because I wrote at least one of them. The way they work is some guy once ported Box2D from C++ to Flash in a halfway manual fashion, but it's really close to C++. So it's ActionScript that looks like C++. Then there came the guys like me who decided, I can whip up a Python script with a bit of regex and some crazy trees and convert it automatically to JavaScript. The result that you get is not quite optimal, to say the least, but it actually works, as you have seen. There are these different ports of Box2D. The one I actually recommend you is the one by Heiko Behrens. which is basically he took what I did as a quick hack over a weekend and actually made it usable with the most recent version of Box2D for Flash. It's being converted. The good thing is also in comparison to the other versions, the conversion script is open source. So should there be a new version, you can theoretically just run it again and get the new one. Multiplayer. Yeah, my slides scale nicely. You can see they have fluid images, but the text doesn't quite work. So I'm going to do hand waving. WebSockets basically suck for gaming. Why? They use TCP. TCP is much better than server. Do you have something new? Server, do you have something new? But the problem is that it's still in order. So it's like your boss that always monitors you and makes sure that you're done with your task before he gives you the next one to even look at. This is not what you want for games. For games, you want to kind of have the thing like on a stock floor where everybody's shouting at each other. Something gets lost, well, okay, not that bad. It's much worse when you have a 1 second interrupt where you can't control your character anymore just because there was one packet that was dropped. Sadly, there's not much we can do about that. I actually think it's very well possible to write games with WebSockets, probably even action games, if you can compensate the latency well by doing predictions, which is really hard when you combine it together with a physics engine that is more complex. So if anybody in here wants to feel like a real hero in the HTML5 world, write a multiplayer physics engine. Otherwise, I'll have to try. The really cool thing, though, is Node.js. And that's like the perfect thing for writing multiplayer games in JavaScript. The evented architecture works really well. And together with Socket.io, you have a library that actually takes care of WebSockets and makes them work. You can reuse your code from the client side, that's JavaScript, to the server side. If you really hate JavaScript, like some people certainly do, you can get pretty close by using GWT or GWT to write everything in Java, which again helps because you will have to share a lot of code between your client and server when you have predictions running. In short, the open web is ready for games. Not just applications, but also games. They work. They even work on mobile devices now. If you don't believe me, I can show you afterwards. There are a lot of rough edges, as I told you, with audio, with WebSockets, with generally everything. That demo you saw with the iceberg, when I started developing this, my Mac froze. Like 1 in 3 times when I looked at that demo. The whole machine froze completely. Which is when you know, yes, I'm living at the bleeding edge. But it's so full of great opportunities, and the web is probably by now the biggest platform there is. Casual gaming and indie games are really starting to grow and gain market and traction. And I really think the web is going to be the platform for this. So go forth and hack. Yeah. This is basically the end of my talk, which isn't quite optimized for that resolution. If you want more of that stuff, crazy demos and HTML5 game development, follow me on Twitter, read my blog, visit me on Google+, or steal this presentation. Theoretically, there was a QR code, but it's not visible.
In gaming, I assume you have to use a lot of threading, which JavaScript by default is not really capable of. So how do you work around that?
Actually, you don't really need threading to write games. This is something relatively new in the gaming industry as a whole. For simple 2D games, like most of the games you would want to run on the web, it works. The other thing is you kind of have very massive multi-threading when using WebGL. On a modern GPU, you have 512 cores that actually you can abuse to do a lot of calculations in parallel. If that's not enough, you have WebSockets. There was a nice demo of running the physics simulation inside of WebSockets. There is some web workers, sorry. And there is some overhead associated because you can't share state, but it actually works. So in my opinion, it's fine. And mostly if you're a single person or an indie developer, you don't even want to have too much multi-threading because that's a massive amount of complexity.
No questions? Okay. Thank you very much.